A differential equation is an equation that relates a function to its derivatives. So if x of t is a function, maybe an unknown function, but it represents some function, then taking the derivatives, x prime of t, x prime prime of t, repeatedly taking derivatives, will give you a whole list of functions. So if x is an unknown function, then so is x prime, so is x prime prime, and so on. And differential equation will be an equation that relates x and any number of these other functions, x prime prime, etc., together. And I will just write dE for differential equation, usually. So here is an example. Maybe you've got this equation, x prime of t equals t times the sine of x of t plus 3 times x prime prime of t. So this is a differential equation because it's an equation relating x, x prime, and x prime prime. And interestingly, also t can show up. Okay, so this is an example of a differential equation. Let's compare this to something that you have seen a lot, which I'm going to refer to as algebraic equation. Something like 3 plus x equals 2. So these are the kinds of equations that you would solve in elementary school or middle school or something. And in this situation, people didn't focus so much on what x is because it was always the same kind of thing. People didn't focus so much on the type of thing that x is because it was always the same type of thing, and that's a number. It's always a number. And so usually with these equations, it would be an unknown number, and the task would be to solve for it, meaning find a number that, when substituted, makes the equation true. So we refer to the number -1 in this case as a solution to this algebraic equation. We use the same language here for differential equations, except instead of an unknown number, we have an unknown function. And we would also say that if you give a particular function, I don't know, t squared, if this function made the equation true, if substituting this function into the differential equation gave you a true, correct equality, then you would call this a solution. Now this is not a solution, probably. I just randomly wrote down this function. But you use the same language. Given a differential equation, you want to solve it. That means find a function that makes it true. For an algebraic equation, if you want to know whether a number is a solution or not, like -1, you would substitute -1 in for all the x's showing up. And then you would check whether the left-hand side equals the right-hand side. For a differential equation, if you're given a particular x of t function, and you want to check is this a solution or not, you would have to substitute it in for all of the x of t's showing up, and then you'd have to take its derivative and substitute that in for all the x primes, and then take a derivative again and substitute that in for all the x prime primes, and so on as many times as you need. And it's the same deal. You're checking, is the left-hand side equal to the right-hand side? So probably if you substitute t squared in here, you will find that it's not a solution. Now often, with the differential equation I wrote down here, it's actually very hard. I don't know how to solve this one. I don't know if it's possible to write down a solution in a nice way. And that will happen usually with differential equations. If you just write down a random one, it's going to be too hard. So it's actually, it's a good skill to know how to solve the easy ones, but it's not as helpful of a skill as you would think, because the differential equations that typically come up are typically ones you just cannot solve. So the early portions of our course will be focused on learning how to solve various differential equations. But later on, we will also mainly be focused on how to understand aspects of a differential equation, or learn something from a differential equation, even when you can't solve it. Like, what can you still do without solving?